All right, welcome to Wednesday. I'm taping this on Tuesday morning. So the responses I got, do we want to do this live, was a resounding no. About 70% of you said no. So we're going to drive on what we've been doing. One thing I will note, I have not been getting emails from anyone from this particular class. Some classes I'm getting a lot, some other classes I'm getting zip, and you're one of them, which either means that you're getting this and we're doing a good job, or you're getting lazy and you're saying, yeah, whatever. Let's not do that if that's the case. Like I said, make sure that you're coming to class with all the answers. Don't wait until I call up the answers to figure out you got something wrong. You got plenty of time to send me an email. Hey, how do you do number 14? I'm lost. Help me out, type thing. So make use of your resource. Now, if that's not the case and you're getting it, then we're doing great. All right. So let's see. Your homework was 11.5, 1 through 16. All as always. I'll call out the answers. You'll grade and then answer question 1 on Google Forms. Here we go. Looks like 1 through 8. Each one has 2 answers. Okay, number 1, the circumference in instructions said leave all your answers in terms of pi. Okay, so number 1, the circumference is 14 pi and the area is 49 pi. Number 2, circumference is 240 pi and the area is 14,400 pi. Number 3, the circumference is 5 pi and the area is 25 over 4 pi. Now, if you change these all into decimal, then go ahead and do that math for yourself and make sure you confirm you get the same answer as I did. Number 4, the circumference is 12 pi root 2, and the area is 72 pi. Number 5, the radius is 10, and the area is 100 pi. Number 6, the radius is 6, and the area is 36 pi. Number 7, the radius is 5 and the circumference is 10 pi. Number 8, the radius is 5 root 2 and the circumference is 10 pi root 2. All right, find the circumference of the rim in the air. Okay, so question number 11 is both circumference and an area. So their circumference is 57 inches approximately. I'm doing some rounding there. And the area is 254 square inches. Number 12, once again, this is rounded, 237 square feet. Number 13, 24 ounces, 24 ounces. Number 14 is 11.3 inches. 15, 984 square feet. And the last one, number 16, is 36 feet. 36 feet. Okay, count up how many got wrong, answer question 1 on the Google Forms, and we'll drive on. Okay, so nothing going on this week. We're continuing on. And then we'll take a test next week. So 1 class on Monday, and then we'll do chapter review. And then we'll take a test on Friday. Yeah, the test will be online, and it will be multiple choice test. Multiple choice test. So contain your enjoyment and excitement. Oh, one other thing. For those of you that are failing to take attendance on Tuesdays and Thursdays, let's see, right now it's 10 o'clock when I'm recording this, and I only have 9 people out of 15 that have taken attendance. Make sure you're taking attendance on Tuesdays and Thursdays. I'm going to count you absent if you do not take attendance. Oh, and Caitlin, yeah, let's go back to calling you Caitlin. All right. Here's your homework for tonight. Okay. Today's kind of interesting lesson. I would say this is more of an algebra lesson than it is a geometry lesson. And what I mean by that is, in algebra, I give you a technique or give you a formula. You just basically use a formula. Today, you're going to get 2 formulas. It's pretty much plug and chug. We're not going to prove any. Well, I am going to prove something to you, but we're not going to do a formal proof. But you get 2 basic formulas. They're pretty easy to use in the sense that they're easy to understand and what to do. Algebraically, they're a little complicated. And obviously, you'll be doing it with a calculator. Just be careful. Some of the questions will say leave in terms of pi, and other ones will just be what's the answer? So they say, what's the answer? They want you to multiply by 3.14. I've never confirmed in this particular book whether if you use the pi key on your calculator, is that what the book is using, or they're using 3.14. Generally, most books use 3.14 rather than the pi key. So if you're using the pi key on your calculator, when it says to multiply by pi, just remember your number will be slightly larger than if you were to use 3.14, because remember, pi continues onwards past the 4. Okay, so we're going to do something, we're going to calculate an arc length and a sector area. So you don't know what this means right now. You will in a second or two. It's not that complicated. The formulas are ugly, but it's a pretty easy lesson. You guys have heard of pie charts, right? You've seen pie charts. Here's a pie chart. Not sure what it says: sales, first quarter, second quarter, third quarter, fourth quarter. In the business world, they talk about quarters just like we do here in school as well too. So, if you're a business owner and you're tracking, how much did you make or how much did you sell for this particular first 3 months of the year type thing, you might make a pie chart. And, this one clearly shows that during the first quarter is when you sold most of your things. So if you were I don't know who sells the most. If you were you sold things for Super Bowl mementos or something like that. Since the Super Bowl happens during the first quarter, you would expect most of your sales to occur during your first quarter. I don't know. There's a crummy example. Each one of those little slices of the pie, we're going to be calling sectors. So today we're going to be calculating the area of those particular sectors. All right, so in your book of truth, I need to write this one down. So we're going to define sector of a circle. It's going to be the area. So we're doing area now. The area bounded by 2 radii and an arc of the circle. So let me draw you a picture. So there's a circle. There's 2 radii. And if I just color that particular region right there, that's what's called the sector. So sector of a circle. So it's 2 radii, and also you got to include the arc, obviously, the arc that would go between the 2 radii. Okay, so that's what's called the sector of the circle. 2 big ideas today. We're going to be doing something called arc length and sector area. And you're like, well, wait a minute, I thought we already did arc length. We did arc measure. We'll talk about that here in a second. We did arc measure. We did not do arc length. So what the heck is arc length? Well, I pulled out that sector from the circle. That's the easy part to understand, sector area. And we'll talk about what arc length is. Arc length is literally the length of the arc. In other words, the red portion there, how long that particular part is. We did arc measure. Remember, arc measure is the angle that it describes. Okay. But today we're going to be doing how long is that red portion there and how much stuff is contained in the yellow portion there. And so we're basically doing area and arc length. And for me, I don't know, I think I've told you this before in class, I always got arc length and arc measure mixed up because, for me, I don't know, I would think arc measure would be the distance instead of arc length, but maybe that's just me. Okay, so recall from arcs is basically what I was just describing there. Recall about arcs. We have a symbol for arcs. I'm not using the actual symbol here in PowerPoint. They don't have it. It's more a curved surface above the AB, but it's the portion of the circle that goes from A to B in the shorter version. Remember, we have major and minor arcs. So when there's 2 letters, it's the minor arc. When there's 3 letters, it's the major arc. And we talked about the measure of AB. And remember, the measure of AB is measured in degrees. So how much around the circle do you go if you go from A to B, in the minor arc here? So we call that the arc measure. And remember, just recall the one of the big things we got from arc measure is that the measure of the arc is equal to the central angle. So the measure of arc AB is whatever the central angle is. Okay, so that's your stimulating your recall from the previous chapters when we dealt with arcs. Okay, but today we are literally going to be doing arc length. That's how far it is from A to B, the short way around. Now we will be doing the major arc as well too. All right, so here's what I need you to think. We're a talking proof. I'm going to talk you through why this formula is what it is. All right, so we want to measure how far it is from A to B. So what do we know? Well, we know that the distance in degrees from A to B Well, that would be equal to the central angle. We also know we have r is the radius, and we also know, well, if we were measuring the distance from A to B, we've already measured one distance around the whole circle. Obviously, we call that the circumference. That's 2 pi r. So the distance from A to B is some percentage of the circle. It looks like to be about 90 degrees, so therefore it's about a quarter of the whole. So I'm doing this with my eyeball here. So it looks like from A to B is about a quarter of the full 360 degrees. We're going to use that in order to get to where our formula comes from. So here's how it works. So we know that circles have 360 degrees. So if I took that 360 degrees and I multiplied it by the percentage of the arc length, in other words, what percentage is from A to B in relationship to the entire circle, in this case it looks like to be about 25%, then we would get to the answer. But we can do that because we know that the central angle is the amount of the degrees that the arc measure is. So we know that if we want to find out what that is as a percentage, we simply take the arc measure, which would be x degrees, and we put it over 360. So for instance, if the measure of that arc was 90 degrees, 90 over 360 would be 1/4, 25%. If A to B was half of the circle, we get 180 degrees over 360, or 0.5, or a half, right? 50%. So if we took that and then multiplied it by the circumference, we would get to what we want, which is literally how far it is from A to B along the arc. Okay, so that is the actual formula, and hopefully that made sense. That's a talking proof right there, not a formal proof, but that is 100% a proof of why that formula exists. So let's write that down. Okay, so arc length, not arc measure. Arc length is equal to the measure of the arc or the central angle, either one's fine, over 360 times 2 pi r. Why 2 pi r? Because that's the entire circle circumference. Why x over 360? Because remember, the distance from A to B would be some percentage of the entire circle. So that's why the formula is as it is described. Okay, so I list x as both the measure of the arc and the central angle. You could get either, they could give you either one. They could say that the measure of the arc is, x degrees, or they could say the central angle is x degree, and they're talking about exactly the same thing. Got it? Okay, you're gonna like these they're not that challenging, but they are. Okay, so let's see how this works. Let's do one together here. It says calculate the length of arc AB. So arc AB. So in order to do that, well, we need to know the measure of arc AB. Well, we know that it's listed there. It's 60 degrees. We need the radius 5, and we need the formula. So the formula says x over 360, where x is the central angle or the measure of the arc, times 2 pi r. So all I need is the central angle or the measure and the radius, and I got both. So it's just a plug and chug thing. So we plug in our numbers, we chug through that calculation. So how would you do this with a calculator? For me, what I would do is I would just simply multiply everything on the top there. 60 times 2 times pi times 5, and then divide by 360. That's how I would type that into a calculator. Okay, if you were doing it by hand, I would do 60 times 2 times 5, all divided by 360, and then multiply that by 3.14. Because a couple things will probably cancel. You can see that a bunch of things will cancel. You could reduce that fraction right from the very start, so you get 1/6. 1 times 2 times 5 is 10, so you get 10 over 6. And then you got to multiply that by pi. So when I do that in my calculator, I get about 5.2 units. I'm flipping to the homework real quick. Does it say? It doesn't say at all, round to the nearest whatever. A couple of the questions say leave in terms of pi, and others do not. Okay. All right. Let's do another one. So this one does say leave in terms of pi. Leave in terms of pi. All right, here we go. So it's asking us to calculate two, the major and the minor arc. The minor arc is AB, and the major arc is ACB. So we'll do it doesn't matter which one you do first, we'll do the minor arc first. So let's do BA, or AB. So let's see, we need the measure of the arc. It's not listed, however, the central angle is listed as 120. Therefore, if the central angle is 120, then we know that the arc measure is 120. Okay. The radius is 9. Therefore, we're just going to plug those two values into our formula. Once again, with a calculator, 120 times 2 times pi times 9, all divided by 360. This one does say, oh, I'm sorry, it says leave in terms of pi, so we're not multiplying by pi. So it's 120 times 2 times 9 divided by 360. And then tag on a pi, and we get 6 pi. Good? All right, how about for the major arc? Well, how many degrees is the major arc? Let's see. Well, if the minor arc is 120, there's 360 degrees in a circle. 360 minus 120 is 240. So the major arc is 240 degrees. The radius is still 9. So those are the two values that I throw in. And once again, it says leave in terms of pi. So 240 times 2 times 9, all divided by 360. And then tack on a pi. And I'm getting 12 pi units. Cool? Got it? All right, so that's what you're going to do for arc length. Arc length. Let's talk about arc measure. I'm sorry, let's talk about sector area. So the area of a sector. So, got to come up with a formula. Got to come up with a formula. So this is your proof. I got to come up with a formula. So we're going to do it exactly the same as we did for the previous one. Well, we know that the arc measure is x degrees, and we know that the radius here is r. Okay. We also know the area of the entire circle is pi r squared, and that's the area of a circle, and we know that there's 360 degrees in a circle. So if we were just doing the sector AB, right, how much area is there, it would be some percentage of the entire circle. So that's what we're going to do. So how do you figure out what percentage it is of the entire circle? Well, it coincides with its degree measurements. In other words, if we knew how many degrees that x was, let's just say it's 90 degrees, it looks like it's about 90, and we put that over 360, that would give us 0.25 or 25%. It's 25% of the entire circle. So if we took that and multiplied it by the area, pi r squared, we would get the answer we're looking for. So there's your quick down and dirty proof of why that is the formula for area of a circle. And it's very similar. The only difference is instead of multiplying by 2 pi r, you're multiplying by pi r squared. So these are pretty memorable formulas. So please write this down, book of truth. So the sector area is equal to x over 360, where x is the measure of the arc, or the central angle, either one, and then times by pi r squared. Cool, got it? Okay, and remember you can always pause the video and go back if you need to hear that again. All right, so we'll do just a couple quick examples here. It says calculate the minor area of AOB. AOB. And why did they have to say the minor area? Because remember, if you say AOB, it could be that larger portion of the circle as well, too. So that's why they either say the major or the minor there. All right, so let's see. AOB, and let's see. Do we know the measure of the arc? Yeah, it's 60 degrees. Do we know the radius? Yep, it's 5. That's all we need to plug into our formula for area of the sector. So let's see. X was 60, R was 5. This one doesn't say leave in terms of pi, so we're going to do the whole darn thing. So let's see. 60 times pi times 5 squared, all divided by 360, is approximately 13.1 units. Not bad, right? All right, let's do the same problem as the previous one, except this time let's do sector areas. All right, so it says calculate the area of the minor and major AOB. The minor and the major sectors there that are defined by AOB. All right, and we're going to leave the answer in terms of pi. We're going to leave the answer in terms of pi. So we'll do the smaller, the lighter shaded portion first. All right, so there is your formula, x over 360 times pi r squared. We know that the central angle is 120, so therefore the measure of the arc is 120 as well, too. We know the radius is 9. That's all we need to plug into our form. It says leave in terms of pi, so don't multiply by 3.14. So 120 times 81, that's 9 squared, all divided by 360, and then tack on a pi, we get 27 pi units. And this should say units squared, units squared, units squared. All right, let's see. The major one, well, where am I getting the 240 from? Well, if the minor was 120, 360 minus 120 is 240 degrees. So we're talking about the dark green, or the darker of the two greens here. And the radius is still 9, so those are the numbers that we're going to plug in. All right, so we get 240, and we're leaving these in terms of pi. So 240 times 81 divided by 360 is 54. Tack on a pi, and this is in square units. So there is your answers, or there are your answers. Cool? All right, so there are definitely some more challenging ones, obviously, tonight for homework. Enjoy. We'll do one challenging one, and then we'll call it a day. All right, so here's a challenging one. So it says, calculate the area of the shaded region. Calculate the area of the shaded region. So, well, the area of the shaded region is a portion of the sector area, but it's not the whole sector area. So let's see, how could I figure this out? Anybody want to wager a guess? So one way of doing this, and it would be the preferred method, would be, well, think about the entire sector there that bounded by OY and OX, right? That entire sector, that would include the little tiny shaded portion, right? That would be the entire area. And if we were to subtract from that the area of the triangle region, we would get the shaded portion. So tonight for homework, that's kind of what you're going to have to do. You're going to have to, I think these are questions, I'm looking, 13 through 18-ish. They're going to give you some weird thing. Just come up with the basic form, and they're pretty much done. Basically, what we're doing right here. All right, so let's see. The sector area minus triangle area, that would give us the shaded region. Okay. All right, so let's see. What do we got to do first? We got to do the sector area. So the sector area is bordered by OY and OX. Well, we can do that. So for the sector area, let's see. The formula for sector area is x over 360 times pi r squared. So I need the angle measurement, or the measure of the arc. The measure of the arc looks to be 90 degrees. So where am I getting that from? Well, it's a right triangle. So therefore, the arc measure is 90 degrees because the central angle is 90 degrees. And the radius, therefore, is listed as 10. So this one isn't too bad. I would encourage you to leave for these, leave them in terms of pi until you get to your final answer, and then multiply by 3.14. Okay, so let's see, 90 times 100. So that's 9,000 divided by 360. That's 25. So 25 pi. So there's my area of the sector, right? From that, I got to subtract the triangle area. So what's the triangle area? That one's easier. 1/2 base times height is the formula. So the base is 10. The height is 10 as well, too. 100 divided by 2 is 50. So let's see, what's my formula? It says sector area, we calculate that as 25 pi, minus triangle area, we calculate that as 50. So 25 pi minus 50. Now we we'll pull out the pi. In other words, multiply by 3.14. So 3.14 times 25, all minus 50, is approximately 28.5 square units. That wasn't too bad. I mean, the hardest thing is coming up with the formula itself, okay? So there's only a few of those tonight for homework. Hopefully they don't give you too much trouble. But as always, you can email me for hints or help on your homework. Please do that, because I'm lonely. No, because, that's what I'm here for. So that's it for today's class. There's your homework once again. And with that, I'll conclude, and I will see you guys on Friday.